Homework 6, problem 2, for a cylinder with a locked-in polarization that points along the axis of the cylinder, find the bound charge density and then sketch the electric field for these three cases where we haven't shown here, but the size of the cylinder is L and the radius of the cylinder is A. Okay, and so sketch the electric field in those three cases. So the first is actually pretty easy. We want to find sigma naught, so sigma or sigma b, the bound surface charge. This is n hat dot polarization. Well, the polarization in this is z direction. N hat on the surface is, of course, on the side of the cylinder is in the s hat direction, so s hat dot z hat is 0, so we get no bound charge on the surface. Then on the top, of course, we have n hat is equal to plus z hat, and on the bottom we're going to find that n hat is equal to minus z hat. And so from this we can say that sigma b on the top is going to equal to plus p naught, and sigma b on the bottom is going to be equal to minus p naught. And now comes the interesting part, which is sketch these fields for these three different cases. For the first case, right, I'm going to have L be much, much bigger than A, and so that essentially is going to tell us that I'm going to have a charge here, a little disk of charge up here, and the disk of charge is going to have a total charge Q is equal to plus pi a squared p naught. And here at much, much further down, right, we're going to have another disk of charge, and this disk of charge is going to have minus pi a squared p naught. Well, this is just what looks like a physical dipole, right? So this is an expression that is, looks like a physical dipole. And so drawing the electric field, it goes from the negative to positive, right? And that's how the electric field flows. Or from positive to negative, sorry. So that's how the electric field flows. And so this is just going to be our normal physical dipole field. Okay, and so this is for case 1. For case 2, so leave this around for some reason. For case 2, we have, let's read it off. Case 2 here is when A, which is the radius, is much, much larger than L. So that's going to look kind of like parallel plates. And so let's draw those. So let's draw our parallel plates. And so I'm going to drop the perspective here, because if I don't, you're only going to see the top plate. But dropping the perspective, we should see this is our top plate, and it has positive charge all along uniformly around this top plate. And so this has positive charge P naught. And then right below that, right, we're going to have our bottom plate as a negative charge uniformly throughout the entire surface. And so this has the minus P naught, so this is sigma is minus P naught. The other is sigma is positive P naught. And the electric field here is easy. It's just pointing in the down direction, right? So this is what the electric field looks like. It points uniformly from positive to negative in the down direction. There is not that much of an electric field outside. We know there's a little bit of electric field outside, so maybe if I had my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, but my 14 electric fields drawn on the inside, I might get one electric field going like that on the outside. Okay, and it would much, much weaker on the outside than the inside. That's one of the things that we want to represent. So a lot on the inside, maybe 2 on the outside. And that's it. Okay. Now for case 3, when they're about the same size. So this one is a little more interesting. So this actually is relevant for the picture we started out with. And so if I draw a disk at the top and a negative disk at the bottom, okay, and so the top disk is positively charged, the bottom disk is negatively charged, and just filling it in like that. Then we're going to find for the electric field that we have the electric field lines that are going to flow from positive to negative, right? And I did not give myself enough room here. And that should be about good for these 3 different situations. Again, I wasn't asked to calculate the electric field, I was asked only to sketch it. And so there are my 3 different sketches for the electric field. Okay, thank you. That was problem 2.